Hello friends, welcome to our first session of robofans network. Here we are going to introduce you with some basic components used in robotics such as DPDT switches, LED, LDR and of course breadboard. First, let us see the working principle of normal breadboard. We see breadboard is divided into three parts: part 1, part 2 and part 3. Here part 1 consists of two strips. One strip from this and second strip this one. Here from this block 1 to block 5 is one strip, and from 1 to 5 is another strip. This strip is again subdivided into two parts, part 1 and part 2. If in any one of the part of the strip, if we connect a voltage source in pin 1 of strip 1 over here, then the same potential will occur across this 5 block of the pin. Similarly for the second part of the strip also, if you apply any voltage source over here, these 5 strips of the strip will have the same potential. Similarly for this also, and part 3 of the breadboard is similar to part 1 of the breadboard. When we move to part 2, here these pins are vertically connected. It means if we apply a voltage source at this point, same potential will occur along the strip.
In the second part of this session, we will deal about LED. LED stands for light emitting diode. It is just a PN junction diode which, when excited by voltage, gives light as an output energy. The voltage requirement for the LED circuit is about 3 to 3.5 volt and the current requirement is 2 milliamps. Applying KCL, that is Kirchhoff circuit law, we can see that the resistance for standard 5 volt power supply is about 1 kilo ohm resistance. Now, identification of the pins of the LED is a crucial factor. Generally, for a loose LED, the pin which is smaller in size is a negative pin and the pin which is larger in size is a positive pin. But in a circuit, we cannot define the pins by the pin size because it is soldered. So, we need to define another factor to identify the pins of the LED. Generally, the pin which is connected to a larger semiconductor piece, that is this one, is a negative pin, and the pin which is connected to a smaller semiconductor piece is a positive pin. Suppose for this LED, this pin is longer, so this pin is the positive pin, and this pin is smaller, so this pin is the negative pin. In this LED, this pin is the positive pin and this pin is the negative pin. We have assembled this LED in a breadboard on two different vertical blocks. This is a positive lead of the multimeter which is analogous to a battery positive terminal, and this is a negative lead of the multimeter which is analogous to the negative pin of the battery. Now the negative lead of the multimeter is connected to the COM terminal which is the common mode negative, and the positive pin is connected to the voltage/ohmic terminal. It is the positive terminal. If we connect the positive lead of the multimeter to the positive pin of the LED and the negative lead of the multimeter to the negative lead of the LED, we see the LED glows, and in the multimeter we can see the corresponding voltage across the LED. Suppose if we reverse the polarity applied to LED, that is the negative lead to the positive pin and the positive lead to the negative pin, we see the LED does not glow.